Greetings and salutations, my mini mathematicians. I hope you're having a fabulous day and I'm so happy you're here. And I miss you. So you get to deal with Video Bar. Yay, Video Bar. So I took some time to make you a great video. Up on the screen you will see your notebook. We're going to pause the video for 2 minutes for you to set up your notebook. 1.2e, Examining Real-World Context Without Solutions on Desmos. Please pause the video for 2 minutes for kids to set up their notebook. Okay, so our lesson purpose is practice solving real-world problems and checking for reasonableness. If the answer solved for, that we found, does not match our context, there's no solution and the problem is inconsistent. Inconsistency. Ooh. Okay, so we have some lesson notes. Let's look at our Desmos lesson. The first screen asks us, find 4 consecutive even integers whose sum is 224. Okay, what are those 4 even integers? Please pause the video for 1 minute for students to figure out with their groups. Oh my gosh, did you find that what you solved for was not an integer, therefore it's an inconsistent word problem and no solution? Exactly. You got 72.6 repeating, 76 2/3. That's not an integer. Integers don't have decimals or fractions. Awesome. Let's go on to screen 2. Screen 2 lets you know about what an inconsistent word problem is. Not every word problem has a solution. When a word problem does not have a solution, the problem is said to be, good, you guys, inconsistent. If you didn't say it, let's try it right now. 1, 2, 3. Inconsistent. One more time, the word is inconsistent. When might a word problem involving coins have no solution or be inconsistent? Coins. Well, can I have a partial coin? No. So partial, oops, gotta spell check that. Partial or negative amounts of coins. Perfect. Let's submit to teacher and move on to the next one. Abby solved an age problem and she got a mixed number for person's age. Abby says the word problem is inconsistent. Is she correct or incorrect? What do you think? That's right. Abby is... Oh, what do you think? Abby is... Abby's incorrect. Ages, years, months, weeks, and days can be partial amounts. I am 31 years, 4 months, and 5 days old. We could convert that into a mixed number. Let's share with the class and let's move on. When might a word problem involving age have no solution then? Age. Well, it can be partials. Age would have no solution if, that's right, negative age is impossible. Cool. Let's keep going. When might a word problem involving perimeter have no solution? Well, perimeter is a length. A length's like a distance. Yeah, perimeter. Save my answer over here. Yeah, negative age is impossible. The same thing as negative length is impossible. Or if the side length of one side of one or more sides is a greater total than the perimeter. Or if the side length of one or more sides is a greater total than the perimeter. That doesn't make sense. Let's rephrase this. Or if less than all the sides total to be greater than The perimeter. Cool. Awesome. Share with class. In your notebook, define and write an expression for each unknown quantity or quantities, and an equation or inequality represent the word problems. I want you to record just your inequality or equation below. So let's work on the first one together. The width and length of a rectangle are consecutive multiples of 5. Consecutive multiples of 5. And what's important is I made this word problem to be writable for you to still be able to annotate. Okay, if the perimeter of the rectangle is 125 meters, what is the length and the width of the rectangle? So we're going to do this first one together, and you're going to do the rest of them with your group. So let's get some space to work in our notebook. And this is slide 6. So on slide 6, let's get some room. What are our unknowns here? Well, our unknowns are the width and the length. If the width and the length are both consecutive multiples of 5, that means if one of them is, let's call the width W, then the length, if I'm at one multiple of 5 and I want to get to the next, like 5, 10, 15, 20, I just add 5. And of course we know that this is in meters, so I'm going to write that meters. So we're trying to find the perimeter, and this shape is a rectangle. So when I look at a rectangle and I want to find the perimeter, my favorite is twice the width plus twice the length is equal to the perimeter, which is 125. So now let's solve this. Distribute. Combine like terms. Hope you're following along in your notebook. Subtract 10 from both sides. Divide by 4. Take half and half again. And you get the width to be 28 75 hundredths. But didn't that have to be a multiple of 5? 28 75 hundredths, yeah, it ends in a 5, but that's not a multiple of 5. It's not when I skip count by 5s I ran into it. So on slide 6, we need to just record our inequality or equation. Oh, it was an equation. I had 2W plus 2 times the quantity of W plus 5 equals 125. Submit, and let's move on. In your notebook, solve. We just did that. Solution a complete sentence. If the problem has no solution, explain your reasoning. This problem is inconsistent because, oh, I always misspell that, because the width ends up being 28.75, which is not a multiple of 5. Hence, this problem has no solution. Awesome. Let's share that with the class. Wonderful. I would like you to work through the rest of the slides with your group, working in your notebook, sharing your answer with the class so we can be seeing each other's work. I will also post out worked out solutions attached to the lesson, as always, the teacher key, so you can see your worked out solutions if needed. Continue working, and I will see you next time. Thank you very much. Have a great day. Do your very best. Be nice to everyone. Bar out. Video bar out.